Okay, in this video I want to talk about the last piece of the puzzle for making a word counting application in processing, and then kind of talk about some ideas and some directions to go in applying this newfound ability to count words in a body of text and what types of things we might do with that. So just to start, like I could probably stand here for like the next 3 hours and show you example after example after example of visualizations of word frequencies in documents. This is a project from 2003 by Jonathan Harris called Word Count, which is just looking at the frequency of words in the English language. And we can see here, number 1, the most common word the, number 2 of, number 3 and I could scroll through and look at different words, and I could find a word like hello and see where that word ranks. The reason why I'm looking at this, though, this might be the type of thing as an exercise you find yourself. Sorry, let me just get back to the beginning here. This might be something you take as an exercise to build a visualization of word frequencies, and I'll show you a couple examples of processing that do this for you. The other thing that I want to point out here, though, is in a lot of in-text analysis, there's a concept known as stop words. Junk words, common words, these words that seem meaningless, that if we're trying to figure out, is this a positive text, a negative text, is this a text by a very conservative author or a very liberal author, what might be what gender is the author of this text? Word counting can unlock a lot of clues to these types of questions, or mysteries, in fact. And often, there's this concept known as stop words. Okay, well, I need to count all the words in a text, and then these words that are like really common in everything, these pronouns, these junk words, I should just throw them away. Because what I want are the meat, the content words, words like happy or sad, or words that have like a lot of meaning to them. What's interesting is that there's been a lot of recent research, and I want to point you to this book called The Secret Life of Pronouns. The author James Pennebaker goes through and discovers the power of actually just counting the junk words themselves. And there's also, if you link here, there's a lot of exercises that you can try, and show you a picture and type some text about it, and it will count your words and give you a clue into what you were feeling or thinking about, or what some personality traits based on what you wrote. So I just want to encourage you to take a look through some of these scenarios. I'll try to have some more examples of different visualizations and different analysis topics. This might be the kind of thing that you think about doing an experiment around in processing. But before you can do any of this stuff, before you can do some type of analysis or some sort of visualization, you need to figure out, how do I pair a string of text with a number, its count? Okay, to start down this path, let's go back and think about a data structure, a way of storing information that hopefully that you, that I, that all of us are somewhat familiar with. By the way, I'm very self-conscious about what pronouns. Don't read that book if you ever want to just talk and not just think about, am I saying I or we too much? Am I detached? Am I connected? Okay, but I'm going to put that aside. Let's you and me, I, you, we, whatever, let's think about an array. What is an array? An array is an ordered sequence of information. An array of numbers, for example, might be like 32, 91, 3, 13, 14, 67, 90. These could all be counts. 32 could be the number of times the word hello appears. 91 could be the number of times the word goodbye appears. So maybe we could have another array with strings in it, and the strings in that array match up with this array. And that could kind of work. There's a nicer way of doing this. An array is ordered by, and each element can be referred to by its index. 0, 1, 2, 3, etc. But what if I could name elements of an array? What if I could say, this element is named Dan. This element is named Jane. This element is named Joan, etc., etc., etc. What if I could name each one of these elements? And this is actually quite useful if I were making an inventory list. I want to know, like, how many markers do I have? I have 10 markers. How many pencils do I have? I have 3 pencils, right? This is the way we often store information in like a database. I have this many of this thing, this many of this thing. The temperature on Monday was this. Monday is 72 degrees. Tuesday is 81 degrees. There's a lot of scenarios where we want to pair strings of text with a value. Naming the elements of an array is one way of doing that. And if I could say Dan appears 32 times in a text, Jane appears 91 times, Joan appears 3 times, then this type of data structure, an array that instead of numerical indexes has names, would be very useful. And in fact, this is a very common data structure in the life of a person who works with code and programs and that sort of thing. In Python, this is known as a dictionary. It's also sometimes referred to as a hash or a hash map, and probably lots of other terms we could come up with to describe this type of data structure. In processing, processing has something called an int dictionary. And an int dictionary pairs a string with an integer. There's also a float dictionary, which pairs a string with a floating point number. There's a string dictionary that pairs a string with another string. So, name and address. These are useful data structures for storing information in a generic way. So, int dictionary is what we can use for, associative array. That's another way. It's another term for this sort of thing. Anyway, int dictionary is the perfect thing in processing to take care of storing words and their counts. How do we use an int dictionary? Well, it's an object like anything else. I'm going to call it words, for example, is a new int dictionary. So this is just making an empty int dictionary. And then I can do things like say words.set, hello to 50. So now I've paired the number 50 with the word hello. In this data structure, 50 and hello are stored together, and I could always ask, I could say words.get hello. Much in the way with an array, we would have said, like, if this was, words index 2, that gives me the number 3. Words.getHello, that gives me the number 50. There's also a function which is going to be very useful in this particular example, which is just words.increment. So if I say words increment hello, whatever the value of hello is, increase it by 1. And this is the key piece that we'll use, that we'll use to build this word counting example. For every word in the play Hamlet, increment its value in my int dictionary. Look at the first word, increment it. Look at the second word, increment it. And if it's not there, the int dictionary will know if it's not there, give it its first value of 1. If it is there, increase its value to 2. The next time, increase its value to 3. So this is exactly the data structure we can use to do word counting. So let's go and finish this example. I'm going to quit out of the browser. And remember where we were. This is where we last left off. Every single word, one at a time. Well, now, what do I want to do? What I want to do is have an int dictionary, and I'm going to actually call it concordance. So concordance is a term to store a list of all of the words or tokens in a document and something about their context, where they are. In some ways, it's somewhat similar to the idea of an index. And in our case, what I'm going to store in this particular concordance is every single word and the number of times it appears in that document. So the first thing I want to do is make a new int dictionary. Then what do? Let me go through every single word. Remember, what did we do in the last example? We took the play Hamlet, we joined it all together, we split it up into an array. Every single element of that array has every single element of the array is an individual word that appears in the play Hamlet. So what can I do? I could say concordance.increment words index I. But let's start in a slightly simpler place. Forget about Hamlet for a second. If I say concordance.increment hello, concordance.increment goodbye, and then let's increment hello 2 more times. Imagine that this is this is the code we're going to run right now. Increment hello, increment goodbye, increment hello 2 times. Let's now look at the concordance in the console, and we can see, what do I have down here? I have, sorry, I have hello 3 times and goodbye once. So the dictionary, the size is 2, hello is 3 times, goodbye is once. This works. So instead of doing hard coding all of these words and counting them, I just need to go through every single word in the play Hamlet and call increment on it. So let's come back, and get rid of this and put this down here and comment this back in, And now let's run this. And let's look in the console. Look at this. Most of the words, almost all of the words in Hamlet appear just once. But I could start scrolling up, and we're going to find, like, oh yeah, the is 133 times. So this is not sorted. Of is 576 times. So you can see this is very, very easily a very quick way to use this dictionary data structure to store all the counts of all the words. Okay, so what are some things that we might do next? So first of all, I want to stop doing this drawing thing, which is making me totally crazy. And we don't need index anymore. So now, okay, so a nice thing that we could do with int dictionaries, it has a lot of functions that'll let us do more stuff. One thing we could do, we could sort. So I missed kind of a key piece of information here. So what is the int dictionary doing for us? Pairing a string with a value. Pairing a string with a value. Terminology that's important here is this is known as the key. It is the key to unlocking the value, and this is the value. So if we want to sort our dictionary to give us all of the words in alphabetical order, we would sort by key. If we want to sort our dictionary to give us the most infrequently used words first or the most frequently used words first, we would sort by the value. So keys and values you're going to see, and if you look at the documentation, and actually let's just go do this together. If I pull up the processing site and look for int dictionary and look at a lot of the possible functions here, you can see has a key, increment. There's a lot of these functions referred to sort by keys reverse, sort by values. So feeling comfortable with the idea of which is the key, which is the value. The key is the string, the value is the number. That's something you definitely want to get used to. So let's go and say concordance sort values reverse. So sort values reverse should, hopefully I spelled that. No, I did not spell that correctly. Sort values reverse will sort by the counts in reverse order, meaning descending order, meaning the highest counts appear first. So if I run this and we look down into the console and kind of scroll up to the beginning, we're going to see the most frequently used word is the followed by and, followed by of. If I kept going through this, though, we're going to find the with a capital T was counted separately. Those are not the same string. Processing is going to consider strings as case sensitive. So the with a capital T, absolutely different than the with a lowercase t. So something that I think would be worth doing with the code here is saying to lowercase. This function to lowercase takes the string. Oh boy, did I miss an important detail, which I want to fill in at some point. Takes the string and converts it to lowercase. So now what this is doing is any word that's in that text, before we put it into the concordance, let's make sure it's lower string. So we should get more than just 860 times for the, because it's now going to be a combination of the lowercase and the uppercase. So let's run this one more time. And we can see here, the is now 993 times. So we can see that now the words are sorted by their counts here, and that's what we've got in the console. Okay, the next step would be to visualize this information somehow. Well, how would we possibly visualize this? We need to somehow go through every single word that is in that dictionary. How do we do that? I think this is right. So there is a function called keyArray, which gives all of the keys, all of the words that are in that dictionary into an array of strings. The reason why we need that is there's no, we need to look through all of the words in that dictionary, and we need something to loop through. Something that's easy to loop through is an array. So we can ask the dictionary to just give us all of the keys. And once I have all of the keys, I can say, and I could say print line the key followed by, and now the count is using the get function. Whoops. I can get the count out. Okay, so look at this. If I say get on a dictionary and we give it the key, it's going to pull out the value associated with that key. Whatever that string is, give me back that value, and that's in count. So if I were to just say print line all the keys in their counts, and I'm going to say no loop, so it only does this once, we can now see that I've got everything now here, and if I scroll, somehow if I make it all the way back up to the top, we can see, there we go, oh, I lost some of the console. Oh well. Anyway, you can see that this is a way of iterating through the entire dictionary and getting every string associated with the count. It's very hot in here under these lights. I'm getting very tired. So I'm going to take a break in a minute. You don't really care about this, but anyway, okay. So I'm going to stop here actually. What could I do? I'm printing everything to the console, but I could use the text function, and I could use the count as the font size. That would give me something very, very close to exactly what we saw with that first word counting example that we looked at on the web. And I think what I'm going to do is just show you also, I'm going to pull up, some of these examples are there for you. If I go to, word counting, example of, so if I open up this example, I don't remember what text this is using. We can see here A Midsummer Night's Dream. We can see here is kind of showing us a simple visualization. You might try to create something like this. The is the most common word, and is the second most common word. I is the third most common word. Another scenario that you might look at, which is kind of interesting to think about how you would accomplish something like this. You can take a look at this example. This example is doing the same exact thing, but it's actually animating over the text as it's counting all the words. So for each word that those words should be wrapping to the next, oh yeah, they are. I forgot that I just zoomed in. So, so each word, it's sorted, and as it's going through, the words are growing based on its count, and the spacing is being worked out manually. So this is something you could think about doing as well. How could you create a visualization of the number of times a word appears in a document? How could you make that visualization animated? Some other things you might think about are what does it mean? Like, what if I compare this text with another text? How do those words look next to each other? There's a concept known as tf-idf, term frequency inverse document frequency. So let's say I look at Midsummer Night's Dream and Hamlet. They're both probably going to have the word the in it a lot. But Midsummer Night's Dream is going to have the word puck in it quite a bit. But that won't be in Hamlet. Hamlet will have the word Hamlet in it quite a bit, and it won't be in Midsummer Night's Dream. Those are two characters that are in those plays. tf-idf, term frequency inverse document frequency, is a means for looking at words that appear a lot in one document but not in the other. And this might be a way of determining key words associated with a piece of text. If you look at all the New York Times articles, what are some words that appear across all the articles, but certain words appear a lot only in certain articles, might give you a clue to the key words, a sort of automatic way of tagging those articles with some type of concept. So, we could go very far with this, and I could spend hours and weeks and video after video of different word counting and text analysis scenarios. So this is just a little bit to get you started, and I encourage you to try some stuff out and look at the examples. And we're going to put this aside, and in the next set of videos, we're going to start looking at other types of data sets besides just plain old text. What if we're getting numerical data from some data source? Okay, boy, this video is 16 minutes and 49 seconds long right now, if you're still watching. Okay.